Hey guys, if you're watching this, this is the Stat Tool 1 review, and we just cut the video this part. But right now what you see is the Stat Tool 1 Quizlet. So you're probably doing some review right now. You can copy paste this link in here, just quizlet.com/class 3349108, and you will be at the Quizlet. Right now you are doing for test 2 at this point. This is, what is this, spring 2017? Is that what we're in? You have chapters 9, 10, 12, 15. Now, if you're watching this in the future and it's not spring 2017, then make sure you cover the right chapters for your test. And this Quizlet right here has lots of great information, most of which created by me at this point. If you see more when you go in, students have probably created some stuff. Really good, really great way to help and go over the material. And so now we are going to go over to the test. So let's start reviewing the test. Here we are with the first question. Once again, if you have any questions, feel free to ask. And you might hear me during this video responding to people online who have questions. So once again, this is the online review. Also, we have individual questions where we go through them individually, and it's more of a walkthrough. So this is more the in-class type review you would get, where we have the individual questions. So once again, check out the list. You're in a list probably right now with all of the videos that show like what's going on. And for you, they'll be uploaded just here in this coming weekend, going over each question specifically, showing you some really great visualizations on how we found the answers. So here you're dealing with my ability to create these answers in the moment. So let's start with question 1 and make sure to ask the questions if you have them. So we have a fair two-sided coin, to which I do not have one on me today. Does anyone have a two-sided coin? Two-sided coin. We shall find one. Say we have a fair two-sided coin which we flip. If the first 3 coin flips were to come up tails, what is the probability that the 4th coin flip comes up tails? You ready? Oh no! Okay, this is a special coin. There's a quarter here. So we have a fair coin, and we're going to flip it. And say we were to get tails, tails, tails. Now, what is the probability that the 4th coin flip comes up tails? The answer is 0.5. It's what I sometimes call the gambler's fallacy, or the law of averages is the trick to this. Nice job, online people, and in-class people. But the trick is that it's not based off of the past. These are independent trials. The coin flip does not care what happened in the past. So a really good trick question that's caught a lot of people. We do not care about the past, and the answer to the question is 0.5. Because the coin flips of the past tell us nothing about the coin flips of the future. And this is perceived to be a fair coin, and say it is a fair coin. What is the probability of getting 5 tails in a row? And let's go down here and open up a Word document. And we're going to put this down below so we can kind of view what's going on. 5 tails in a row. Well, I want you to explain to me, when you flip a coin and get 5 tails in a row, what happens? I just want you to tell me, you flipped the coin, talk to me. You flipped the coin, onliners too, anybody. You flipped the coin and what happened? You got tails? Tell me more. Wait, what'd you say? Say that again. You said I got tails and then I got tails again, and then I got tails again, and again, and again, and again. Each of these trials are independent of each other. And when we say I got tails, and then I got tails, and we keep on saying it happens, well, we are talking about I got tails 5 times in a row. So I got tails, and then I got tails, and then I got tails, and then I got tails 5 times. Now, when we multiply events, they need to be independent. Once again, does this coin care what it got in the past? It does not, which means it's independent. It means that the trial when we flip it this time is not going to be any way influenced from the trial this time. That is independence. When you say event A does not change the probability of event B, as in the first flip does not change the probability of the second flip being tails. So with this in mind, we can shorthand this. And that is going to be 25, 12.5, 13.25, 0.03125. Please tell me if I'm correct. I am correct. There we go. So that, just put it in the calculator, solve it, and that's what you get. And once again, they will correct me if I get something wrong, I hope. I have to do up here and do it in my head. Does that make sense to everybody, why that is the probability of getting heads 5 times in a row, and then why we can solve it? This is the rule of independence. Make sense? Good deal. Ask all questions you have. Once again, the videos will go more in depth and maybe go a little slower, but I'll try to go slowly. Question, go ahead. Probability is just a percent of the time something would occur. Probability is unitless. You wouldn't say, you would say flipping a fair coin would, and we could say this, flipping a fair coin would result in 5 heads only 3.125% of the time. So in 5 coin flips, yes. So the rule of independence is the same as, it's a requirement. And I will say this, if you do more advanced classes or continue on, everyone close your ears if you want. The rule for multiplying is actually the probability of A and B occurring is the probability of A times the probability of B given A. And so if A and B are independent, the probability of B would be the same given A. So there's actually more rules. Blank that out of your head. That's not part of this class for the moment. If 2 events are independent, you can just multiply them together. That's what we're doing in this class. There is more to it in later classes, which we're not going to get to at the moment. But if you have independent events, you can multiply them together straight through. So that's something we've learned right here, is you can multiply events that are independent straight through. You can just take 2 events that are independent, multiply them to say what's the probability of this and this. Does that make sense, Andrew? That's what we've learned in this class. If 2 events are independent, like A does not influence B, we can just multiply the 2 together to get the probability of A and B occurring. It's like me saying, the probability it rains in Knoxville tonight is, and I hit a wrong button there. The probability it rains in Knoxville tonight is 10%. What is a sports team you care about that's playing tonight? Any sports team? Say the Knicks, maybe. So the Knicks have a 55%, let's say 60. The Knicks have a 60% chance of winning this season from what we know. What's the probability it rains in Knoxville tonight and the Knicks win? Just multiply them together. Do you think the Knicks care if it rains in Knoxville? Do you think they say, oh, it's raining in Knoxville, we better give them something to brighten their day? No, it's their independent events. Well, what if I said, what is the probability a blizzard, or we get a huge torrential downpour tonight is 1%. And what is the probability your power goes out? Now, you might say, or let's put it to 2%. You might say 2% of the nights in Knoxville, your power goes out. And 1% of the nights of the year, we have like huge storms. Does that make sense, kind of? 2% of the days of the year, your power goes out. 1% of the days of the year, we have huge storms. But if I say, what's the probability we have a huge storm and your power goes out, are those independent events? Are they? Is your power going out dependent upon a storm? Yes. So the probability of your power going out would do what if there was a storm? Would actually be higher. So that's why you can't multiply them together, because this 0.02 is no longer 0.02, because the probability of your power going out is actually dependent on there being a storm. So this, if this test question said this, these are fake made up test questions right now, but the probability of there being a huge storm is 1%. The probability of your power going out is 2%. You cannot multiply these through because it won't be correct mathematics. These are dependent events. Does that make sense? It does? Good. That's when you cannot multiply. But with the Knicks and it raining, the Knicks don't care about it raining. Those are, if events are independent, then you could say one event and you wouldn't know the other. You ready for your coin? You ready? Oh, did you get it? No. Question. There's a question in class. Go ahead.
So for part 2, we did like the multiplication. Technically, part 1 couldn't be the additional, even though it's on 2 sides, even though it's 50% chance. But
with part 1 is basically going over the fallacy of the law of averages. And it's literally just saying that the probability of tails will not be influenced by past events.
like P of heads equals 1 minus.
Yeah, you could do that. So you could do the probability of heads is 50%. 1 minus probability of heads is tails. So you could do complementing stuff on that. Yeah. Yeah. Good way of looking at it too. Because it's still what's just probability of tails on a fair coin. Yeah. Suppose we have two events, A and B, with the probability of A being 30% and the probability of B being 50%. Find the probability of A or B, assuming they are disjoint. And here's Brian Stevens' rule for disjoint. I say A occurs, and as soon as we know A occurs, if they are disjoint, i.e. mutually exclusive, what do we know about B? Cannot occur. Also, there are videos that I have, chapter review videos. Has anyone ever watched one of those? Maybe for last test? There's chapter review videos also, and I show the hands right there with thumbs up, thumbs down. When things are disjoint, like grades in a class, maybe this is an intro class. Maybe it's intro to basket weaving. And the probability you make an A is 30%, the probability you make a B is 50%. Can you make an A in the class? Can you? Can then you also make a B? Those are disjoint. There are events that are not disjoint, though. I know this question says they are disjoint, but could you eat at Burger King for lunch and then McDonald's for dinner? Not saying you want to, but you could do both of those. So if you say, well, I could do this and this, could it rain tonight and the Knicks win if they're playing? Yeah, those are not disjoint events. Does that make sense? But if events are disjoint, this has been a good question on the test. If events are disjoint, are they independent or dependent? So let's figure it out. You ready? Making an A in the class, nice job online. Making an A in a class would be independent of making a B or dependent on making a B? Making an A depends if you make a B. So if they're disjoint, because think about this, if you know you made an A, then that totally makes B not happen, right? So it's very dependent. So a good note there is that disjoint events are very dependent because once one happens, the others can't. Online they said, and I think they figured it out, they're doing complement right here. I think, Tiambe, is it? Tiambe, I don't quite understand your question. I'll answer the question to what this is, and feel free to, you might be doing the next one. Find the probability of A or B. What is the probability of A or B? Simply put, if the probability of A is 30% and the probability of B is 50%, given that they're disjoint, the probability of A or B is, does that make sense? When events are disjoint, we can just add them up because we won't be double adding up stuff because they can't both happen. So you either make an A or a B, and the probability of making an A or a B is 80%, or the probability of an A or B. Does that make sense to everybody? Fast follow-up questions if you have them. You're welcome. No, you're welcome. So for those who don't know, we're watching, this is an online class also, so you might see me talk to the onliners. Great participation, everybody. Find the probability of A and B, assuming they are independent. Now, here's a trick. There's so many tricks we can play on you guys. And I try to expand upon these things because this is just one practice test. If we are to multiply, and this is a key thing, this is the multiplication rule, and they must be independent. The word or relates to addition and relates to disjoint. The word and relates to multiplication and relates to independence. You must have independence. Once again, I will say it. The word or relates to addition, and they must be disjoint, i.e. the rule this. One happens, the other can't. The word and relates to multiplication. All you do is multiply them, and they must be independent, as in knowing one event tells you nothing about the other event. As in, it rained tonight. Did the Knicks win? I don't know. That doesn't tell me anything. There is a huge thunderstorm outside right now. Is my power out? Are those independent? Those are not independent. Can we multiply them? No, because they do not meet the independence rule. So you can only multiply when the independence is met. So let's take a look at this. If these events are independent, all we do is substitute. And this is now the probability of A and B. And we get here, and please correct me if I'm wrong. Nice job, Tiambe. She got the same answer online. Suppose we are considering a person drives to work one day. Let event C represent this person being rear-ended. Oh, I remember this one. This got people. This is a tricky question. By another vehicle before they get to work. Let event D represents this person gets to work safely without having any sort of collision. And so C is getting C is getting rear-ended and D is getting to work safely. I have no idea what the complement of these events are, which is 0.00003% or 0.0003 or 0.03%. But I want you to think about this for a moment. You're going to make one drive to work. You could get to work safely, or you could get rear-ended. And by safely, we mean you don't get in any sort of collision, as it says. Is getting to work safely dependent upon getting in an accident? So what do you know about these two events? They're very what? Correct, they are disjoint. And since they are disjoint, they are very what? These events are disjoint because you can't get rear-ended and not get in an accident. And we just said earlier, oh, nice job onliners. You can't get, and so in class is going to figure it out now, you can't get rear-ended and get to work safely. Like, they both can't happen. So by knowing one, you get all the information on the other. So these events are very, very dependent. They are disjoint and very dependent. Disjoint events are dependent because you would say me getting to work safely depends on somebody crashing into me. Does that make sense? As soon as you say somebody crashed into me, I would know the answer to did you get to work safely without an accident? So the answer to this question is, this is a trick question. We can't multiply events that are dependent. That is what is going on right here. Does that make sense to everybody? Questions, anything? This test, when we gave this question, there was a bunch of like, what? No, oh, because people, they see A, C, and D, and they want to multiply like this. But every time you do the probability of C and D, what must you check? The two events are independent. You must check. I know that so far, this caught so many people off guard. This is the big one. All the like, no, you shouldn't put trick questions on there. It's a little tricky, but that's why we put it on there. Question? I answered it? Good. Good job. Not possible. This is a trick question. We can't do this. Or some people actually wrote in the probability is actually 0. Because you can't, because if you get to work safely, you can't have gotten rear-ended along the way. Does that make sense? And C and D does mean multiply, but only if they're independent. But these are disjoint events. So if one happens, the other can't. So what's the probability of them both happening? If one happens, the other can't. So what's the probability of them both happening? 0. So yeah, that's exactly it. So you could have wrote, it's a trick question. You could have wrote, we can't multiply. You could have wrote, these are dependent events, but the probability is actually 0 because you can't get to work safely and get rear-ended going to work. I'm gonna have some fun with the pictures on this when I make the videos. Fun times, here we are. We're doing a good pace. Look at this, we're on question 4, but they're about to get longer. And I gotta start thinking on these. You ready for this? A major airline wants to find out if additional charges for baggage affect the airline passengers who choose to fly. The airline passengers choose to, the airline they choose to fly with and how often they fly. They decide to survey passengers who are flying on their airline. The airlines decide to select 30 of their flights. We're gonna take 30 airplanes here over a 1-week period and survey all the passengers on the flight. What sampling method is being used? This is pure memorization. Bingo, Ty. What do you guys think? What? Cluster. Now some people say, but they're doing it randomly. How do we select the clusters? We select clusters at random. What do we then do to a cluster? A complete census. That's where we take, nice job. We take 30 random flights, doesn't matter that it's over a 1-week period, that's kind of superfluous information, and we take all the customers on those flights, all the passengers. So we do a complete census of each cluster. In cluster sampling, a cluster is taken, and then a complete census is done on each of the clusters. Does that make sense? Question?
So why? Because at first I thought
Sure.
clusters, but then I thought convenience because they're only testing their airline.
So if it's really convenience, look for something that's really, like, here would be a good example of convenience, which I don't think is on here. It could say the airline decides to sample the first 200 customers that day. If it said like first 200, or it could say something like the airline decides to sample the first 200 flights that come through or something like that. If you see first blank of this, convenience should be something that's really easy, that is a hallmark of like, did you really do this correctly? Because convenience sampling is a flawed sampling method that you shouldn't do. You should never make a convenience sample. A lot of people do it, but it adds in a lot of bias. So you get convenient bias right there. What is the sampling frame? I hope someone has the key open. You gotta stop and think about these. The sampling frame is defined as all people we have access to sample. The sample is all people we sample, where the population is all people or things, I should say, that we are actually interested. We've got some disconnect online on what the answer is. Let's see, they say B or C. All passengers that fly this particular airline. All passengers that flew this particular airline during the week they did the survey. And it would actually be answer, and they're saying B, but it's over the week though. Does someone want to double check the key? Because I'm 99% certain on the key it's going to say C. It is C on the key. And so because, remember, these are the people we have access to. We're not going to see someone in our sample if they didn't fly during that week. Does that make sense? Yes, good job, onliners. This was a tricky one again. This is why even I have to slow down. Remember, the sampling frame is defined as all people or things we have access to sample. Does that make sense? Where the sample would be all people on these 30 flights who responded. Now, we could get some non-response bias. Someone could not fill out their survey card. We could get some response bias. People could lie or not tell the truth. We could get some undercoverage because we could choose flights that are maybe not international during that week. Like maybe this was the 1 week, like a holiday week, and we undercover non-holiday travelers. So we could talk about the biases that could occur, which we might do in a second here. But remember, the sampling frame is all people or things we have access to. And we're only sampling in this 1 week. So this actually comes into play here. The 1 week period is when we are sampling, and thus we choose 30 random flights, right? So did we have access to anybody who flew our airline during that week? Did we have access to them? We did. We might not have sampled them, but they could have been sampled, right? Hence, all people or things that could have been in our sample is the sample frame. Explain once. Oh my gosh, this is the everything question. This is the like, okay, how many ways can you go? Let's see, onliners, or let's see, start typing some responses as I tie my shoe. So what do we have? I'd rather tie my shoe in a video than like fall over and face plant. Of course, I can edit out whatever I want, but I'd rather not. The video starts up and I've got like a bloody nose. It's like, everyone's like, that was Semester Brian just like fell over during class. Oh, what do we have? The passengers have to pay the bag fee. So remember, whenever you get a question like this, try to be as specific as possible and mention things you learned in class. So try to mention like under coverage, response bias, or non-response bias. How about this? People on the flights who are very dissatisfied because they're trying to collect data on baggage fee, right? How baggage fees. So the survey is going to be something about baggage fee. So people on the flight who are very displeased might leave the flight quickly and not want to turn in their cards or whatever, and thus we might have non-response bias. Does that make sense? These people who are unhappy are not responding. We could also have response bias because the stewardesses could be standing over the people, watching them fill out the survey cards, and then the people might not be giving their truthful response. Like something like that could be occurring. We could have undercovers because this could be during a week where we're running a promotion that has people happier than normal or something like that. Like this 1 week period could not be representative because undercoverage means we did something that's not representative. Undercoverage because I'm sure the airline has more than 30 flights with people who would like to do a survey. Not quite, Ty, because we need to point out why these 30 flights might not be like the rest of our flights. Does that make sense? If we chose a good random 30 flights, Wouldn't that be representative of all our flights if they were a good random? But what if these 30 flights are during like our spring break-a-palooza week and we're handing out free alcohol to everyone on the plane? Yeah, just like, yeah, everyone's like, woo, best airline ever, woo, and they're filling out the survey card, we're getting all perfect scores. Does that sound like it's representative of every week? No. Don't you wish you fly and they say it's spring break-a-palooza week and it's like, yeah, so Brian Stevens said if that's going to happen. No. So in other words, when we talk about undercoverage, we would say, and I think we have another one here, undercoverage because of where the flights came from. If all the flights came from one region, then people in other regions are not covered. Very true. Maybe this week, this one does work. Maybe this week, and I would point to that the week, I think you gave a very strong answer there, Montana. Maybe this week we weren't flying to all of our places, so we undercovered some of our destinations during that week. And maybe baggage fees are higher for like international flights. Like maybe there was less international flights during this week where we took our random sample of 30 flights. So talking about why this week might not be a good coverage of like if you took 30 random flights. So that's good undercoverage right there. We talked about non-response. We talked about response. You could also talk about there might be some sort of voluntary bias. Like maybe people got something for doing this. So maybe they had people volunteering to do it. And that can create bias. Like maybe, and this is people probably volunteering to do this. They're not, maybe there's a little voluntary. I don't think the answer for that one's as strong, but we're usually pretty lenient on these. The key to all of these questions is using a concept you learned in class. Make sure to explicitly say something like non-response bias, response bias, undercoverage bias. Those are probably the key answers, whatever you write. And I'm sure the key has another decent answer on it. Does that make good sense? Nice answers, everybody. Question? Usually we like 2 to 3 strong sentences. We of course don't want you to write a whole novel, but 2 to 3 strong sentences I usually say, like the issue could be non-response bias because people who are very displeased with the service, with the baggage fee, might not want to fill out the card and help out the airline understand what's going on. Because could you see that? People who are just displeased and they don't want to fill out a survey? Like, I don't want to do this. I hate this airline. I'm not helping them out. So they that would be non-response. Because people are displeased, but we're not getting them in the sample because they don't want to respond. So that would be a problem right there. So, and you see I gave that in about 2 sentences worth. So suppose instead that the airline decides to survey passengers on all of its flights on a single day by just selecting every 10th passenger entering each of its planes to take the survey. What are we using right here? Systematic. And systematic does include with it that you would choose a random starting point. That isn't always mentioned because sometimes it's hard to figure out what a random starting point is, but we would choose systematic here because we're going to choose every 10th, and that's a hallmark of it. I want to make clear if it did say choose a random starting point, that is not multi-stage. Multi-stage is when you would maybe choose every 10th cluster, like every 10th flight that day. That'd be multi-stage, where we're systematically choosing every 10th flight, and the flight is the cluster. What if we chose 10 international flights and 30 national flights, or what are they called? Not international and domestic. That's what I was looking for. Thank you. 5 points extra credit. Don't worry. If you're not in this class, you don't understand how extra credit works. It's just a little bump to their grade. So you're like, whoa, 5 points on the test? No. So if we were to choose 10 international and 30 domestic, because our airline flies 75% of the time to domestic and 25% international, and we chose those flights, 30 domestic, 10 international, then what are we doing? And we're going to sample everyone on these flights. Clusters are what? You're right, clusters. The flights are the clusters, and we're stratifying. Stratifying is acknowledging a difference. Once again, stratifying is acknowledging a difference and then sampling in proportion to that difference. Does that make sense? If 75% of our flights are domestic and 25% of our flights are international, and I do 40 flights, well, 75% of 40 is 30. So 30 of my flights that I take, that I do a census on, should be domestic. So stratified is when you sample in proportion to the percentages in the population. And you do this a lot of time not to undercover, Because someone could say, well, domestic fees are lower, so you probably didn't get enough international people, so that's why your survey came out so well. These people are mean. But if we were to do a stratified, then we could make sure that we get the right amount of international. It's like, well, 25% of our customers are international, 25% of our survey was international. And how did we achieve that? By stratifying. We could have also chosen random. If you were to stratify and not do a multi-stage, you would then just choose random customers. You might look at your database and take 25% international customers and 75% domestic customers and send out the surveys via like an automated thing to, like 500 customers where 375, 75% get it from the domestic, and 125, 25% of the 500 get it from the international. Question in class. Correct. In true stratified sampling, you get your individuals through a simple random sample of each strata. That's not multi-stage either, because you have to get the people, and this is a really good distinction where people make little mistakes on the test, is that when you have strata, you create 2 groups or 3 or 4, how many ever groups, you then have to get the people out of them or the items, and the way you get them without multi-staging it is to simple random sample. And the way you get your clusters is your clusters are a simple random sample of clusters. Does that make sense? Because how do we choose the 30 flights? The 30 flights were chosen at random. You have to get the flights somehow. If you took the first 30, that would probably be, wouldn't want to write a test question like that, but that would be like a convenient cluster sample. So that would be, and that you wouldn't want to do that. Clustering has in that you take the clusters at random and then you do a census of the clusters. Stratified has, and we're just going above and beyond with these answers, stratified has that you create the strata and then get the individuals or items randomly from the strata by doing a simple random sample of the strata. So, and I want to make this clear. These are very good memorization things. To go back, look at the Quizlet, that's where that's going to come in use, and memorize. So lots of good opportunities. That's a pure memorization chapter. Woo! A high school student is interested in attending an Ivy League school as long as a student has a GPA of 4.0 and an SAT 4.0. My GPA was nowhere near that. An SAT of 1300. SAT changes so much, but that's a good score out of 1600. There's a 38% chance of getting accepted to any of these institutes. One can assume that being accepted or rejected is independent across the 8 Ivy League colleges. Do you think Harvard or Yale talks to each other and says, we rejected this person, you should accept them? Be interesting if they did, and I hope they don't, and we'll assume for that moment that they don't, which means being accepted to one college is what? Like whatever you are, when you apply to one, being accepted is independent of what happens in the other. Like if you were just looking across Ivy Leagues for these people. So it's independent. So for all these 4.0, 1,300 students, whatever happens to one college, each of them has a 38% chance. What is the probability that a student is accepted to at least one of these 8 schools? And these are the problems that destroy people. Oh, have you figured it out? Okay, don't tell it yet, don't tell it yet. What do we have here? Let's look at it. This is the way I figured these out. The Brian Stevens way of learning it. They could get accepted to 0 colleges, right? What do we want to see? They get accepted to what? At least 1. Does that make sense? We're going to put this in a nice kind of like, we got to put in a color we can see, right? We'll put in that. That's nice, like a brick color. They're getting accepted to NC State. It's not an Ivy League school. And this one over here is what we don't want to see. We'll put this in a sad blue. So we have going on right here. I'll read a second here. So a 38% chance. It's a 38% chance they get accepted to any one school. So literally, you could just generate a random number from the randomnumber.org and say, what's the probability, like, do I get accepted? And if something below 38 comes out from 1 to 38 or from 39 to 100, 1 to 38 would mean you get accepted. So think about this. What do we not want to see here? If you apply to 8 schools, 8 Ivy League schools, and you want to get accepted to at least 1, you do not want to see the 0. And tell me what happens in the 0. The 0 stands for, what does that 0 mean? That means you got declined from all of them. This right here is the event that's going to be the easiest to solve for. Does everyone understand this is what we don't want? That's exactly right, William, right there. We got accepted to 0 schools is what we don't want to see. So if someone said to you, did you get rejected from all the schools? And you said, no, I didn't get rejected from all the schools. What would that mean? Tell me in terms of this question. I didn't get rejected from all the schools. You got into at least one. Does that make sense? So let's talk about the probability of 1 minus the probability of all rejected. Does that make sense? Does that make sense what we're solving right here? 1 minus the probability of all rejected. What is the probability of them all rejecting you? What's the probability of 1 rejecting you? Nice job online. What is it? There's the probability of 8 rejecting you. Because either 8 will reject you or not 8 will reject you, correct? Because we have the event, you get rejected from 8, and the event, everything but getting rejected from 8. Does that make sense? Is this clear? And nice job online, they wrote the complement. 0.62 is the complement of 0.38 for those who didn't see what I did. This is just the complement because you will either get accepted or not accepted, and this is the probability of not getting accepted from 8 schools. And when you get your answer, read it to yourself this way. 1 is everything. Minus is but. This is the probability of getting rejected. Everything but all 8 schools rejecting me. Can you read it that way? Let's read it again. Everything but all 8 schools rejecting me. Actually, I'll read it this way. Everything but being rejected from all 8 schools. Because now I actually said it in order. And does that make sense? Everything but being rejected from all 8 schools is this. Does that visually make sense? How those are connected? Because what is this? Does that make sense? And then if you do 1 minus, it's the complement. These are the tough ones. Watch it again if you need. And this is recorded. This will be posted. So yes. So I guess I'll post this on the YouTube channel too, or it'll be posted on the YouTube. But for our link, it'll be probably there too. We're doing good. How are we doing, everybody? These are the tough ones, and we'll be doing more of these probably. And there will be a more in-depth video on this, but that's how that one is done. The owner of a new apartment building must install 50 water heaters. Let's say that the proportion of all always hot brand water heaters that will last 10 or more years is 25%. We can think of the 50 always hot brand water heaters that this owner actually buys as a random sample. So he's getting these randomly. Ooh, that sounds important. After 10 years goes by, the owner will know the proportion of water heaters out of the 50 she purchased that actually lasted 10 years. This proportion can be thought to be as her sample. Because she took a sample, didn't she? She bought 50 water heaters, and we would know that 25% of them last more than 10 years. The sampling distribution of the sample proportion refers to, let's look, and I believe, here it is. This is what we're going to look at right here. The distribution of all possible sample proportions from sample sizes of 50. Because could she get a sample of 50 that are pretty bad? Could she? Could she get a sample of 50 that are pretty good? Yep. And think about what data she's going to collect after 10 years. She's going to look at that water heater, or the one that no longer exists, and say, after 10 years, this water heater what? Or does not what? Work. So she's collecting what kind of variable on it? Categorical. So it's going to be the proportion of working water heaters after 10 years. Now I want you to take a guess. What's your best guess of the proportion of water heaters that will work after 10 years? 25%. Because it says 25% are expected to work after 10 years. So we'll see this with the David M. Lane applet in a moment, that you would expect 25% of her water heaters to work after 10 years. Does that make sense? So that's what we would expect. But isn't it possible that maybe like all of them could work? None of them could work? But those don't seem like probable events yet. We'll need to find out the distribution to see how likely those events are. The sampling distribution of the sample proportion, which would show us the distribution of all possible sample proportions of sample size 50. Because when we do our p times q over n square root, that will give us the spread of this normal curve right here. Nice job, onliners. Question?
For number 5, so
the answer to that question, did someone, just to quickly review, the mathematical answer to this question was what? Did anyone times it out? It was 1 minus 0.68 to the 8th power, is that correct? You could put it in either way. We're pretty lenient. The graders should know to 0.9782. And is that what other people got? And that's what the key says? Yay, thank you for having the key open so we can double check. And what did you get?
I just
and that should be, if you write 97.82%, A-okay. Great questions. So we'll accept it either which way. The graders should be, I think it says to 2 decimal places or 3 decimal places. The start of the test usually says. I don't like it when we take off points if you don't say things exactly how we want, like, oh, you left off 1 decimal place. Each grader is different, can't promise what will happen to you, but I look to see if you learned how to do the statistical stuff. That's what I care about. One time when I was in 3rd grade, very quick story, I got counted up points for, I think I circled my answers and it said underline them, and they didn't give me any right points. That's not fair. So I think those things shape our lives. So let's see here, and this is so clear. To know what the mean and standard deviation is and the shape of this distribution is, we must check 3 conditions. Because we would like this distribution to be what shape? What shape do we love? The normal curve. We want it to be normal. And what does it mean to pass these 3 conditions? That it's normal. If we pass these 3 conditions, we have a normal curve. We can use the normal curve. So as I always say to my class, condition 1, random. It means it has been randomly selected. Did she get a random sample of 50 water heaters? You bet she did. So you can write up there, write random, and then down below, write, yes, this condition is met because it says she got a random sample of 50 water heaters from this company. Condition 2. No, ooh, great answer. You can write the 10% condition. You can write 10% condition. That's fine. No larger than 10% of the population is sampled. Assuming that this company has made more than 500 water heaters, we are safe. Does that make sense? And we do meet this condition with a reasonable assumption that this company that puts out water heaters makes more than 500 water heaters, and thus we will have sampled less than 10% of all the water heaters the company makes. Now we got to slow down. We got to pause. You ready? Breather. Here, I'll take the question in a second. Take a breather. What kind of data are we working again with here? Categorical. Condition 3. Success failure. The reason it is the success failure is because it is based on categorical data, and this means NP and NQ must be greater than 10. Mathematically check it. Go here and mathematically make it work that we have NP. N is 50. P is 25. NP is 12.5. N is 50. NQ is 75. And NP and NQ add up to N. 12.5 and 37.5 are both greater than 10. Nice job, Sequoia, 5 points extra credit, typing it out online. Perfect answer for the test. And then I would say they are both greater than 10. That's all I would add to it. And you have the perfect answer for it. To check the success failure condition, merely mathematically solve NP and NQ and show they are both greater than 10. N is the sample size, and P is the true proportion, because the company knows after 10 years, 25% are going to work. Question?
So I was going to say, I think you just explained it.
Oh, good.
But,
yeah.
I didn't know how to tell whether something was success or fail.
So a success means that it's NP right here. A success is NP. So 50, we expect 12.5 water heaters to work. And failure and success could be flipped either way. They just both need to be greater than 10 because both NP and NQ are greater than or equal to 10. And greater than or equal to works. It's fine either way. Greater than or equal to is good. Do what? What's the Q? Q is the complement of P. Great questions. Q is the complement of P, so Q is 0.75.
Oh.
Yep. So P is 0.25, Q is 0.75. Go ahead. If it was quantitative, the third condition would be large enough. Nice job. Large enough N, which is based on the sample size. If the distribution was normal, 1 is good enough. If it's lightly skewed, 25. If it's highly skewed, 100. And that's for only quantitative. We'd have to say things like, the average life of a water heater from this company is 8 years with a standard deviation of 3, and it is left skewed. Because maybe they, I don't know, they left skewed, right skewed, whatever. But it is slightly skewed to the left. And if we said it's slightly skewed, this is a total revamping of this question. If we said it was slightly skewed, then what would we have going on? The sample size is 50 and it's slightly skewed. Do we meet the large enough? We do, because that's more than 25. And that is a total revamping of the question. That was just a fake question for the moment. How large would it have to be to meet the large enough condition? If it says lightly skewed, 25. If it says heavily skewed, around 100. And so that's what we have. Usually we try to make it clear. If we say it's very skewed, you should have a sample size of 100. If it's normal, 1 is good enough. If it's lightly skewed, 25, and if it's heavily skewed, 100. And this is not for this question, because this question's categorical. This is not this question. That was a reimagining of this question where the question said something like the average life of a water heater is 8 years. Do you see now it's giving you a quantitative value with a standard deviation of 3? That's the switch, because if it says a quantitative thing, the third condition is large enough. If it says a categorical condition, like categorical thing, like we expect it to work or not work, then it is success failure. No. So Sequoia, this is just a reimagining completely with new numbers and everything. So don't worry about that last part if you don't want, because it's a completely fake new question that would not deal with proportions at all. As soon as you start doing proportion stuff, you are only doing success failure condition. Does that make sense? If it was a question that gave you a quantitative value, it would be large enough. Does that make sense?
Is there a large enough one?
I believe so. We'll probably have one like that. This is probably going to ask us to draw it next. If it was a quantitative variable, then depending upon if it said normal, 1 is large enough, skewed 25, heavily skewed 100 for the sample size. And it would be sample size then. Does that make sense? It's in the Quizlet actually shows a really good definition of that. Scroll to that really quickly. And someone could pause on the screen here if they want. This is the large enough condition right here. We look to see how large N is. If the distribution is normal, 1 is large enough, 25, and that's just a really quick. So once again, promoting the Quizlet. Check that out if you want. Someone's got something else open right there. Okay, question number 6. Regardless of your answers above, what will the mean be? Well, we just said that if we meet this, it'll be normally distributed, and the mean will be P, and the standard deviation will be P times Q over N square root. Does that make sense? How many definitions do you want? And then what did we say the shape will be? If it meets these conditions, right there. So once again, this formula was P times Q over N square root. And write that down right now if you're doing this. P times Q over N, and then it's square root of everything. I want to make that clear. If you watch me do it in the calculator, I do P times Q over, and then there's the over N, and then I square root the whole thing. It's the whole thing square rooted. P times Q over N square root. So you can just write P times Q over N, and then square root of everything. It's square root of everything. So that's what we have going on there. P times Q over N square root. Suppose that after 10 years pass, she finds that 16 of the 50 water heaters still work. Calculate the sample proportion. Can anyone tell me the sample proportion like that?
Sorry.
Okay, question, go ahead. The standard deviation? Yeah, that was that. The p times q over n squared. Yeah, great question. Not 32%. Wait, 16, you're right. I saw the 10. That's nice job, Montana, 5 points. I got something wrong. I saw the 10 and my brain blanked and I thought 10 over 50. Montana is correct. This lady got lucky and 16 out of her 50 worked. This is the formula x over n. And I always double check when a student says an answer that I didn't get, but I saw 10 and the answer is that 16 out of her 50 work. And 16 is x, and 50 is n. X over n equals p hat, number of successes over number of trials. So all you do is divide. Does it make sense to say 16 out of her 50 still work? So in her sample, 32% work. Does that make sense? Yeah, it does. So using your answers and calculate the z-score. But I want us to think about this. Look at this. What is this very close to? What is that very close to? Basically what? Basically 6%, right? How many z-scores is this above? How many standard deviations is this above? About how many? A little more than, careful. What percent is this? What's 25%, right? What percent is this? 32%? What percent is this? 6%? So the z-score is going to be a little more than, just all z-scores is how many standard deviations it is away. 25%, 6%, and 32. Little over 1. Does that make sense? Can we see this visually for a moment? Can you see it? What's 25 plus 6? 31. Do you see that's very close? Because all a z-score, let's do the z-score. You ready? We're going to take observation of 32, p hat, minus mean of 25. That tells us how far they are away. Observation minus mean, p hat minus p, over standard deviation. Observation minus mean over standard deviation. And like we said, 32% is a little more than 1 standard deviation away. Does that make sense? Can everyone see that visually? Do you see 25, 6, and 32 is just a little more than 1 standard deviation away? That's key. So we can see that. It's like, 32, that's just a tiny bit more than 1 standard. What is the z-score again? How many? Go ahead. How many standard deviations in observation is above the mean? Or below, far away, positive, negative sense. So we are 1.14 standard deviations above the mean here. Go ahead.
So you just did observation minus mean divided by standard.
Bingo, observation. And the observation was she observed in her sample 32%. And then we saw a mean of 25. That's what we expected. And then we divided by the p times q over n square root.
Did you do 0.06?
Yeah, I did point. I'll do it again real quick so you can see. Ready? Here we go. 0.32 minus 0.25, observation minus mean, over standard deviation. Does that make sense? Cool. Great job. Observation minus mean over standard deviation. Calculate the z-score, so it's 1.14. Given your answer, would you consider having 16 or more water heaters still working unusual? The answer is, would it be unusual? Woo. Yeah. The answer is no, because it's only 1 standard deviation. Nope. This is just 1. We are literally, and let's pull. The moment when you realize it, right? You're like, oh wait, that's the z-score. I love it. You're like, wait, I get it. And I'm gonna go over here real quickly and show you. I think it's like that, is it? And if we go to above right here, does that look to be that odd? Like super odd, or it's a little unusual. Sequoia put it correctly. A z-score greater than the absolute value of 2 is unusual. Outside of here and outside of here would be unusual. This would occur probably around 13% of the time, rounds to 13%. So I do this way too much. Because what is above here is a good review question. 68, what's outside of 68? 32, what's on either hand? 16, so it has to be less than 16. 95, what's outside of 95? 5, what's one of my hands worth? 2.5. So it has to be between 16 and 25. And sometimes we ask questions like that because you can see here, this is going to be very close to 16, very close to 16. And then this one right here is going to be very close to 2.5. So close to 2.5. So we know that our number here is between 16 and 35. I mean, excuse me, 16 and 2.5. Don't know, typing in the 3's got my brain backwards. So, what's going on? So it's not unusual because the z-score is less than the absolute value of 2. So it's not larger than 2. I think we have time for one. Oh, yes, we got some randomness right here. We love randomness. So a local grocery store is going to give away gift cards. Can I copy this into Word? This is going to make my life easier. The answer is maybe. It's going to be fun if I can't. Come on, come on. Oh, it's going to keep doing that, isn't it? Okay, let's cross our fingers this time. You ready? Okay. Copied it. Yep, we got it. Okay. A local grocery store is giving away gift cards to customers as they check out and pay for their purchases. The contest rules state, amongst one things, that those that win will be awarded prizes ranging from $50 to $5. Use the randomly generated integers below. Answer the following questions. Let 0 and 1 represent gift card winners, and 2 to 9 represent customers that did not win. So we're going to look at 100 customers because there's 20 rows with 5 customers. So let's go ahead and play the game. I would immediately start playing it. And let's see what we got going on right here. Okay. Please tell me if I missed something. What is the button to hit to keep constantly doing this? Top left. Go here?
Go left. So once you have things selected, you go format.
Pick color first.
Pick my color.
Yeah. And then if you highlight that.
Highlight what?
The 0. The entire, and then in the top left of the entire Microsoft Office, go down a tiny bit.
Oh, cool. There it is.
So you don't click that.
Oh, double click it?
It might work now.
Okay. So now I should be able to. Now we're doing it, right?
Go back and I had you undo it on it. There we go.
Nice. Thank you. There's something you learn right there. Right there. I broke it. I think like the way I'm clicking, I'm being all weird about it. This is the fun, like slow part right here. Maybe where I speed up the video. I should be able to just click, right? Because what, the different rows and stuff? Yeah, it's fun, isn't it? Oh, we got it going now. Please don't break. There's a 0 there. Once, and this, I will say this, with these questions, like if you make mistakes, this is where you'll ruin this whole question. If you get a question like this that requires you to use random numbers, I'm kind of just jumping around toward the next one I see, like as close as it is to me, I'll do some checking. But if you make one mistake, you can mess up your whole question. So, double, triple check. Did we get them all? Mm-hmm. We did? Okay. Yeah, so double, triple check these. We'll do more questions here. I might even do the rest of these on my own, just talking through. Like I might jump into a Zoom meeting and do the rest of these myself. That way there's a video of me just doing them so we can have like a full video walkthrough. Because we will have class again here next week, but I don't want to post the whole video like late. So you'll probably see this video after this question, like skip to me, like just like at my place being like, okay, such and such, without everyone here. Sorry that to go through in entirety sometimes takes longer than one class period. So now let's take a look what we have got going on right here. One thing I'm going to do, because I know where this question's going to go, is I'm going to take this last row right here. I'm going to increase font size in it. I'm gonna make the value red for how many winners there were. Really? Oh, did I just make that a, really? Yeah, so now the table doesn't have an extra row on the side, does it? Okay. Well, let's see what the question asks and be careful about it. Based on how they coded the random numbers, what is the probability of a customer winning? Easiest question we got. 0 and 1. What do you get if you put 0 on top of 1 through 9? How many numbers are there? If you took, yep. So 0 and 1 is 2 numbers out of 10. Does that make sense? So there's 2 out of 10 because 0 to 9 is 10 numbers because 1 to 10 is 10 numbers. Does that make sense? It's just like 10 is at the bottom and it's 0. So there is 20% chance somebody wins. In the simulation, what proportion of the time did exactly 2 customers win? So let's be careful here. Here, let's underline it or bold it and italicize it. Sure. And then here. Oh, no. And we have these 3 rows right here. And double, triple check everything. Why am I doing that? Just to call my attention to it. If I was doing this on a sheet of paper, I'd probably like underline them or circle them or something. It's just hard to see, and I can't really change this. I could maybe change the size of them a little bit. Can I do that? Tables are weird. But that row, this row, and this row, I think that's it. So there's 5 rows, unless I've miscounted or anything. Is that correct? 5 out of them. And let's double check the question. In the simulation, what percent of the time did exactly 2 out of 5 customers win? And when you look at this, exactly 2 out of 5 won in 5 of the 20 simulations, which is 25%. Your answer to part 2 is meant to be an estimate of the probability that exactly 2 out of 5 win. What would need to be done to get a more accurate idea of what is going on right here? How could we get a more accurate idea? What could we do to maybe it's 25%. That's a decent estimate. Very simple answer to this. How do we get a more accurate idea? That's exactly what we said in class. I was going to write it down here too. Not increase the sample size. A lot of people write that. And we kind of accept that sometimes. It's like an iffy thing. But more trials, more simulation. This is the simulation chapter. And oftentimes we ask a simulation question like this. Good try at it right there. We would increase the number of simulations. You could do 100 simulations or 1,000 simulations, especially if you're just doing this randomly. You could generate more random numbers. So yes, more simulations, which is akin a little bit to more sample size, a little bit, but say increase the number of simulations is the best A+ answer that we don't even have to argue over, but increase the number of simulations. There will be more questions on this. We see right here, this looks like a chapter 15 part 2 question, but that does it for our time today because we go until 6:20. We just have that question right there. And does that say this one's removed? Question number 9 continued from chapter 16. So that's removed and true, false. My gosh, do you guys want to just do the last little bit here? Let's do it, right? Everyone is free to leave if they want, but do what? Sometimes. Do you guys want to come in? Are you guys next? But I'll be back in 2 seconds. You guys have the tutoring thing next, right? At 6:30? We go like 5 minutes. Okay, thanks. All right, let's do this. They're so nice to us. All right, let's do this. Because then we get this whole video done, we're good, right? Suppose one takes many repeated samples of n equals 50 from a very large population, and that's a key right there, going to help us with the 10%. That is slightly skewed to the right and has a mean of 12.75 and standard deviation of 28.5. What would be the average of the sampling distribution of the sample mean? Well, if the population has a mean of what? So if we kept sampling and we took an average of the samples, what would the average be? 127.5. Because it's like if you say one guy is 5'10", and then I went and talked to 50 guys and averaged together their heights, what do you think the average of their heights would be? 5'10". But the thing is this, is the new distribution is around the same mean, but it's also wetter? Tighter. So we take the original standard deviation of 28.5, and when we do the distribution of the sample mean of sample size n, we do what to it? We take it and divide it by square root of the sample size. So, and I messed that up. 28.5 divided by the square root of 50, which I just found. 28.5 divided by the square root of 50. Does that make sense? The new distribution of the sample mean, yep, let's do it. I like it. It's like, let's do it. So the new distribution of the sample mean has the same mean as the original distribution, but is tighter by a factor of the square root of n. Sound good? And we must meet the three conditions. It says right here, assuming all three conditions are met for the central limit theorem. Given that the central limit theorem applies, what shape will there be? In other words, we have selected these individuals randomly, which it says. We have selected less than 10% of the whole population because this is a large population. We are only selecting 50. And also, it is only slightly skewed, which means the sample size needs to be at least what? 25. Once this goes back to, just to review again, for those who want to see, this goes back to this right here with the large enough n condition. Does that make sense? So when we have large enough n right here, that is met. What shape will it have? The best shape in the world. It will look normal. It will look normal. That's what that all means when we meet those three conditions. Random, 10%, and normal, or large enough n means that is normal. In one particular sample size of n equals 50, a sample mean of 150.7 was obtained. Would you consider this rare or unusual? Now here's the thing people forget, is you can figure out a lot with this open space. Now I know I have the applet right here to cheat, but check this out. Just like you could do, you could take this standard deviation right here and plug it in. And then you could take this mean, which was 127.5. You could take this mean of 127.5. And then you could view on here that in our sample we had 150.7. Is that unusual? You can easily see, if you were to draw this graphic out, you could easily state, my graphic shows that 150.7 is more than 3 standard deviations away. And check it out. We could take observation of 150.7 minus mean of 127.5, observation minus mean over standard deviation. And what have I obtained right now? I have obtained the z-score. I have found how many standard deviations it is away. And it's a little bit like p hat minus p. This time it is y bar minus mu because it is quantitative. So this is y bar because we observe a sample mean. We minus the actual true mean of the population. Then we divide by the standard deviation of the sample mean of the proportion. Oh gosh. Divide by the standard deviation of the sample mean. Sorry, there's no proportions here because this is means. And that's why we have third condition. If you say large enough ever, you are dealing with means, you are dealing with y bar and mu. So once again, this is more than 3 standard deviations away. This is very odd, and I want to point something out. Do you see 150.7? If we had used the original standard deviation of 28.5, was it? Yes. 150.7 is less than 1 standard deviation away for a single observation. It is not odd. But for a sample of 50, is it odd? Yes. Is that clear? With one observation, it would not be odd, but if you saw for 50 an average of this, it would be odd. Because it'd be weird in a sample of 50. Let's do the true false. Let's finish up. This will only be, I promise, 3 more minutes. We will be done. We'll be done just a tiny bit late. Of course, Thank you for everyone saying you are free to leave if you want. I want to make that very clear. Here's the last two. Here we go. Comment cards at a restaurant are an example of stratified sampling. Very false. That would be convenient. Nice job. Extra credit right there. 5 points. Convenient sampling right there because it's nice and easy, just throwing it out. And also voluntary. I would say convenient / voluntary. It's a bad way to do it. And yeah, maybe, not a good idea. Stratifying would be if we told, we said, okay, we're going to sample 40% of our morning customers and 60% of our night customers, because then I'm acknowledging a difference and going to sample in proportion. Suppose that the heights of females in the USA between the ages of 16 and 18 are normally distributed with a mean of 66.25 and a standard deviation of 2.1. If repeated randomly sampling from the population with the central limit theorem applies that a sample size of 2 will result in a sampling distribution that is normal. Yes or no? The answer is... I read it. Come on. Okay. The answer is true, and why? It was already normal. So the new distribution of the mean of sample size 2 will be even more normal. That caught a lot of people. Remember, going back to once again, if there's normally distributed to begin with, 1 is large enough. So if the distribution was normal to begin with, then 1 is large enough of an n, because the original is normal. So anything we make as a new distribution of means from that will still be normal. Does that make sense? Great job. We got through the whole practice test. There will be videos going over each individual problem. There are chapter review videos. I do answer all the emails at bs@utco.edu. Great job, guys. Email me questions, ask them if you got them, and I'll talk to you later.